So welcome to the first video in the organic chemistry section. Now we're just going to start it off nice and simple here with some recap from previous chapters whilst we look at carbon. Learning targets for this video are just being able to represent carbon containing molecules in different forms, be able to explain the bonding and the shapes within carbon-containing molecules, and be able to describe types of covalent bond in these different molecules. We're just going to start with why carbon makes the number of bonds it does. Now carbon, as I'm sure you know, has 6 electrons. Now when we write that as its electronic structure, that comes out as 1s2, 2s2, 2p2. And if I draw this, you can see that we have 2 unpaired orbitals, the 2px and the 2py. Now based on this, you would think that carbon could only make 2 bonds, but as I'm sure you already know, this isn't the case. That is because it is easier for one of the 2s electrons to be promoted to the 2pz. Now this is actually energetically favourable because the energy required to promote the electron is a lot less than energy formed through the formation of 4 covalent bonds rather than just 2. So this is why carbon can make 4 bonds. So the next thing we need to look at is what these carbon containing molecules look like. As I'm sure you're aware, there are lots of ways you can represent molecules containing covalent bonds. So let's just look at molecules only containing single bonds first. Now I've just drawn methane here as this very simple carbon containing molecule. You can see there are 4 lines coming from the carbon. These represent 4 covalent bonds. Now this is just another simple way of drawing methane, and instead of straight lines you have the circled elements just touching, and then more commonly you have your dot and cross diagrams. Now dot cross diagrams can also be shown without the circles. So these are the 4 ways you should be familiar with the drawing covalent molecules from GCSE. In previous chapters, we've also looked at the shapes of molecules, and given that the carbon has 4 bonding pairs of electrons and no lone pairs, the shape around the carbon is your basic tetrahedral. With a bond angle of 109.5 degrees. Now there are other ways of representing organic molecules. We will look into that further in the forthcoming videos. Now carbon containing molecules can also contain double bonds. Again, I've just chosen a very simple hydrocarbon just to explain the point. Once again, there are several ways of representing this. First of all, your basic displayed formula with all the bonds shown as straight lines. And you can once again have your dot and cross diagram. But in this case, there are 4 electrons being shared between the 2 carbons, representing the double covalent bond. Now, if we just focus on one of these carbons, we want to determine the shape. You can see whilst there are 4 bonding pairs and no lone pairs, 2 of the bonding pairs take up the same space for the double bond. Simply think of this as a single bond, so we consider it as 3 electron pairs. Therefore, the shape is a trigonal planar with a bond angle of 120 degrees. Now, this would be the same for the second carbon, which is attached. Now, the final thing to remind you of is just the different types of covalent bond. So remember, all single covalent bonds include sigma bonds. Now this involves either the s or the p orbitals on the carbon atom overlapping directly with orbitals of another atom on the line in between the centers of the 2 atoms. However, when we have a double bond, we don't just have this sigma bond. We also have 2 electrons occupying space either above or below the sigma bond, and this is termed a pi bond. So this pi bond is not as strong as the sigma bond. Hence, the bond energy for a double bond is not just twice the energy of a single bond. And another characteristic you need to know is that once you have that pi bond in place, you can no longer have rotation around that bond. This is very important for when we do isomerism at a later date. So hopefully, you've had a reminder of different ways in which to represent carbon-containing molecules. We've also had a recap on some of the shapes involved in carbon-containing molecules, and also the different types of bonding involved in carbon-containing molecules.